Hello students, let us try to understand fluid in pressure. No, pressure in fluid. Pressure in fluid. All liquid and gases are fluid. All liquids and gases are fluid. A solid exerts pressure on the surface due to its weight. Similarly, fluid have weight and they also exert pressure on the base and wall of the container in which they are enclosed. Pressure exerted in any confined mass of a fluid is transmitted undiminished in all directions. Okay, so pressure is having the all direction pressure. Fluid is having all direction pressure. Have you ever had a swim in pool and felt lighter? Have you ever drawn water from a well and felt that the bucket of water is heavier when it is out of the water? Have you ever wondered why a ship made of iron and still does not sink in a sea water? But while the same amount of iron and steel in the form of a sheet would sink. These questions can be answered by taking buoyancy. In consideration, let us understand meaning of buoyancy by doing an activity. Take a empty plastic bottle, close the mouth of the bottle with an airtight stopper, but in a bucket filled with water. But you see that the bottle floats. Push the bottle into the water. You feel an upward push. Try to push it further down. You will find it difficult to push deeper and deeper. This indicates that water exerts a force on the bottle in the upward direction. The upward force exerted by water goes on increasing as the bottle is pushed deeper till it is completely immersed. Now release the bottle, it bounces back to the surface. Does the force due to the gravitational attraction of the earth act on this bottle? If so, why doesn't the bottle stay immersed in water after it's released? How can you immerse the bottle in water? The force due to the gravitational attraction of the earth act on the bottle in the downward direction, so the bottle is pulled downward. But the water exerts an upward force on the bottle, so the bottle is pushed upward. We have learned that weight of an object in the is the force due to gravitational attraction of the earth. When the bottle is immersed, the upward force exerted by water on the bottle is greater than weight. Therefore, it rises up when released. To keep the bottle completely immersed, the upward force on the bottle due to water must be balanced. This can be achieved by an extremely applied force acting downward. This force must be least, at least be equal to the difference between the upward force and the weight of the bottle. The upward force exerted by the water on the bottle is known as upthrust or buoyant force. In fact, all objects experience a force of buoyancy when they are immersed in fluid. The magnitude of this buoyant force depends on the density of the fluid. Why objects float or sink when placed in the surface of water? Let us do a following activity to arrive at the answer for the following question. Take a beaker filled with water, take an iron nail and place it on the surface of the water. Observe what happens. The nail sink. The force due to gravitational attraction of the earth on the iron nail pulled downward. There is an upthrust water on the nail which pushes it upward, but the downward force acting on the nail is greater than the upthrust of the water on the nail, so it sinks. Now let's try to understand this one in details. Okay, so here is, take a beaker filled with water, take a piece of cork and iron nail of the equal mass, place them on the surface of the water and observe what happened. The cork float while the nails sink. This happens because of the difference in their density. The density of substance is defined at the mass per unit volume. The density of cork is less than the density of the water. This means that upthrust of the water on the cork is greater than the weight of the cork, so it floats. The density of an iron nail is more than the density of water. This means that the upthrust of the water on the iron nail is less than the weight of the nail, so it sinks. Therefore, object of density less than that of the liquid float on the liquid. The object of the density greater than that of liquid sink in the liquid. Archimedes principle. Take a piece of stone and tie it to one end of the rubber steering on the spring balance. Suspend the stone by holding the balance or the steering as shown in the figure. Note that the elongation of the string of the reading on the spring balance due to the weight of the stone. Now slowly dip the stone in the water in a container as shown in figure 10.6. So this is the figure. Now observe what happens when the elongation of the string or reading on the balance. Okay. When will find that the elongation of string on the reading of the balance decreases as the stone is gradually lower in the water. However, no further change in observation. Observe once the stone gets fully immersed in water, what do you infer from the decrease in the extension of the string or the reading of the spring balance? We know that elongation produced in the string or the spring balance is due to the weight of the stone. Since the extension decreases once the stone lowered in water, it means that some force act on the stone in upward direction. As a result, the net force on the string decreases and hence the elongation also decreases. As discussed earlier, this upward force exerted by water is known as force of buoyancy. When its magnitude of the buoyant force experienced by body is the same in the fluid is given body, do all body in the given fluid experience the same buoyant force? The answer to this question is uh, contained Archimedes principle is stated as follows. When a body is immersed fully or partially in the fluid, experience the upward force that is equal to the weight of the fluid displaced by it. Now, can you explain why further decrease in the elongation of the string was not observed in activity 10.6? Archimedes principle has many applications. It is used in the designing ship and submarine lactometers, which are used to determine the purity of the sample of milk, and hydrometer used for the determining the density of liquid are based on the principle. Relative density. As you know that density of substance is defined as the mass of a unit volume. The unit of the density is kilogram per meter cube. The density of the given substance under a specified condition remains the same. Therefore, the density of substance is one of its characteristic property. It is different for the different substance. For example, the density of gold is 19300 kg meter cube, while that of the water is 1000 kg meter cube. The density of given sample of a substance can help us to determine its purity. It is often convenient to express density of substance in comparison with that of water. The relative density of substance is the ratio of its density to that of water. Relative density, density of substance, density of water. So this is all about the